So these notes are for Integrated 2MA. This is the chapter 4 math analysis. This is section 4.4 trigonometric functions of any angle. And before we get into the notes, I'm going to come over here and just use this blank section here. And I'm going to get to unit circles or circles on an XY axis. So I'm just going to come over here to add media. I'm going to come to the G for Google search, and I'm going to type in unit circle blank and see what they have here. This one's fine, but I don't want us to think that it has to be this many units. So I'm going to come choose this one here, and I'm going to insert it. And I'm going to make a copy of this and get a second one that I'm going to do also. So for this, what I want us to do is think about one as an actual unit circle of radius 1, and one that maybe is not a unit circle. So this one here is going to be a unit circle, which means our radius is 1. So if I'm starting here and I'm drawing out to anywhere on this unit circle, this is going to be a radius of 1. And this point here is going to be some x comma y. Now that x is going to be the distance from here to here. The y is going to be the distance from here to here of this right triangle. So this is going to be x, this is going to be y. Now, when I am using a unit circle of radius 1, we know about SOHCAHTOA, where SOHCAHTOA is telling us, helping us remember what our sine is, opposite over hypotenuse, what our cosine is, adjacent over hypotenuse, and what our tangent is, opposite over adjacent. So if I was going to be doing our sine of our angle, and let's call this angle, let me zoom in here for a sec. We'll call this angle, make it a little smaller font. Theta, okay, right here. Then when I'm going to be doing my sine, okay, my sine of theta is going to be opposite, which is y, over hypotenuse, which is 1. And so I end up with y. We talked about this the other day. Cosine of that theta is going to be adjacent, which is x over hypotenuse. And so I get just x. When I deal with tangent of that angle, that is going to be opposite, which is y, over adjacent, which is x. Now, each of these trig functions has a reciprocal. The reciprocal of sine, remember, I always say s doesn't go with s and c doesn't go with c. So since sine is s, it's going to go with cosecant. Since cosine starts with a c, its reciprocal is going to be secant. And the reciprocal of tangent is going to be cotangent. So now when I'm doing these ones, again, these are reciprocals of sine, cosine, and tangent. So if sine is opposite over hypotenuse, then my cosecant is my hypotenuse over opposite. My hypotenuse over opposite, which is going to be 1 over y. Okay, the reciprocal of y over 1. My secant is going to be the reciprocal of my cosine, which is cosine is adjacent over hypotenuse. So now I'm going to go hypotenuse over adjacent, which is going to be 1 over x. For my tangent, tangent again was opposite over adjacent, y over x. Cotangent's the reciprocal, so it's going to be adjacent over adjacent over opposite, which is going to be x over y. And that's what we were using for a unit circle, which is radius 1. So our sine was the y coordinate, the cosine was our x coordinate. If I took my y over x, I ended up with tangent. And then my cosecant was the reciprocal of my y coordinate. My secant was the reciprocal of my x coordinate. And my cotangent was x over y. Now, let's say that our circle does not have a radius of 1. Let's say it's a radius of r. So this is going to be a circle with radius r. So I'm going to start here. I'm going to draw out to this point. This is going to be a radius of r. And this point here is still going to be x comma y. And I'm still going to get it by going this distance, which is going to be x, this distance, which is going to be y. But the difference is when we are thinking about SOHCAHTOA, my hypotenuse this time is not r. So that means my sine is not going to be just the y, and my cosine is not going to be just the x. So again, when I'm doing this, I know that my sine of theta, again, if this is going to be my theta here, is going to be opposite over hypotenuse. So opposite is y, but this time my hypotenuse is r. So it's y over r. It's not just the y coordinate. Cosine of theta is going to be adjacent, which is x, over my hypotenuse, which is r. So again, it's not going to be just the x coordinate. This is when my radius is not 1, any r besides 1. So tangent is going to be opposite, which is y, over adjacent, which is x. So that's going to remain the same. Now, when I'm doing the reciprocals, okay, again, the reciprocal of sine, s doesn't go with s. So this is going to be cosecant. Reciprocal cosine, again, c doesn't go with c. So this is going to be secant. And the reciprocal of tangent is cotangent. So now for these, what's going to happen is I'm going to take the reciprocal like I did of my sine. So if my sine is y over r, my cosecant is, r over y. If my cosine is x over r, my secant is r over x. And if my tangent is y over x, my cotangent is x over y. So what you'll notice is when this is not a radius of 1, it is not just the x coordinate that's my cosine. It's not just the y coordinate that's my sine. The only reason it was up here in a unit circle of radius 1 is because the radius, which is my hypotenuse, was 1. So when I put it over 1, I just got y. When I put this over 1, I just got x. Okay. So these ones over here, we're going to see on the next page. That's how they got those. So if I come over here, here is our situation. They have an angle x, a point x comma y. They have a radius r. Okay. Now, they gave us all of those ratios that I just gave us on the other side. I'm going to make a slight distinction here. X in this case is any x, positive or negative, but what I want us to understand is where we are on the unit circle. So if my point is here in this quadrant, and I'm going to draw my right triangle to get to that x comma y. Yes, this would be x and this would be y, but you have to think about where you are on the graph. I'm on the negative side, so this is going to be a negative answer number here. Okay, so I just want us to understand that. Now, if you're wondering where did they get this equation for the radius, how did they get that? It's just Pythagorean, because that radius is from here to here. That's my r. So if I wanted to find that, I can do Pythagorean. In this case, I'm going to write negative x just to show you that if this is on the negative side, that value should have been negative. Plus y squared equals r squared. When I work that out, this is just going to be x squared plus y squared equals r squared. And I'm going to take the square root of both sides. And when I take the square root of both sides, I have to take the square root of the whole side, x squared plus y squared. And here you see that's where they got the formula. It's really just Pythagorean theorem. Okay, so now, let's say we have a point, and for some reason the parentheses disappeared from it. So let's say we have a point, -2, 3. So let's say I either draw a graph, or I can actually even get a graph here if I want. Okay. Blank graph. Let's see, I want one with positive and negative. Let's see. Or I could just even draw it out here. I'm just going to get this one, see how big it is. Okay, that's reasonable size. Okay, so I'm just going to draw my x and y axes here. Okay. And I'm going to plot that point, this point right here, -2, 3. So I'm going to go -2, 1, 2, 3. Okay, that's where I am. And we know that this point is going to be on a line that is going to form the terminal side. So what I'm going to do is I am going to draw a triangle from here to the origin. And I'm just going to kind of zoom in a little bit. And this is theta. I don't know what theta is, and I don't really care. I don't need it to find all of the values they're asking me to find. What I do know is that this is going to be 3. And yes, this is a length of 2, but it's on the negative side, so that's a -2. Now, my legs can be positive and negative. My hypotenuse will always be positive. So now I'm going to use Pythagorean to figure out my radius, basically. So I am going to go -2 squared plus 3 squared equals my radius squared. So I'm going to get 4 plus 9 equals r squared. 13 is equal to r squared. So the square root of 13 is r. So this is going to be the square root of 13. That is my radius or my hypotenuse. Okay. So now what they want us to find, they want us to find the sine, cosine, and tangent. Okay. So if I'm going to find the sine, cosine, and tangent for this angle, my sine of that angle is going to be opposite, which is 3, over hypotenuse, which is 13. I'm going to rationalize by multiplying the top and bottom by root 13. And my final answer is going to be 3 root 13 over 13. That is going to be the sine of that angle. Now, my cosine of that angle is going to be adjacent, which is -2 over hypotenuse, which is root 13. Again, multiplying top and bottom by root 13 to rationalize it. I end up with -2 root 13 over 13 as my cosine of that angle. And tangent of theta is going to be opposite, which is 3 over adjacent, which is -2. So really you can think of it as a -3/2. Okay, the whole fraction's negative to -3/2, and that's my answer. Now the next section is just showing us where things are positive and negative in the quadrants. So here, when it says between 0 and pi halves, which is quadrant 1, x is greater than 0, y is greater than 0. They are saying that my x coordinate and my y coordinate are both positive. In quadrant 2, where my x is less than 0 and my y is greater than 0, my x coordinate is negative over here and my y coordinate is positive. Down here in quadrant 3, x is less than 0, y is less than 0. So in this quadrant, my x and my y are both negative. In quadrant 4, my x is greater than 0, my y is less than 0. So my x is going to be positive, my y is going to be negative. That's really what it's saying. Now, if you think about these in terms of sine and cosine, remember that my sine on my unit circle is going to be associated with my y coordinate. So wherever my y coordinate is positive, my sine is positive, or my my y coordinate is negative, my sine is negative. Same going for the x, which is my cosine. So in quadrant 1, sine, cosine, tangent, all of them are positive. Over here in this quadrant, my x is negative, which means my cosine is negative. My sine is positive because my y is positive. And then my tangent, which is sine over cosine or y over x, is going to be a positive over negative, which is a negative. Down here in this quadrant, my sine and my cosine are going to both be negative. So when I find my tangent, which is sine over cosine, I get negative divided by negative, which is positive. So my tangent is positive. In quadrant 4, my sine is going to be negative because my y's are negative down here. My cosines on this side are positive because my x is positive here. And then my tangent, again, is sine over cosine, negative over positive, and then negative divided by a positive is a negative. So now, if we look at this one is showing us everything. It's showing us all 6 of them. And really, I just focus on sine, cosine, and tangent, but I want to make sure we understand that this is going to be true, that if my sine is positive, its reciprocal, which is cosecant, will also be positive. So over here, my sine is positive. My cosecant, which is its reciprocal, is positive. My sine is negative. Its reciprocal cosecant is negative. My sine is negative. Its reciprocal cosecant is negative. When I'm dealing with cosine, and cosine is positive here, so is its reciprocal, which is secant. Here cosine's negative, so is its reciprocal secant. Here cosine is negative, so is its reciprocal secant. Quadrant 4, cosine is positive, so is its reciprocal secant. And then tangent is positive here, and so is its cotangent. Tangent is negative here, so is the cotangent. Tangent is positive here, so is the cotangent. Tangent is negative here, so is the cotangent. So again, if we know where our sine, cosine, and tangent are positive and negative, the reciprocals will be the same sign. Now, example 2. So in this one, we want to figure out where this angle is, in what quadrant. If we know that our cosecant is greater than 0 and our tangent is, our cotangent is less than 0. So if my cosecant is greater than 0, the reciprocal of cosecant is sine. So really, where is my sine greater than 0? And here, tangent's the reciprocal of this. So where's my tangent less than 0? That's really what I want. So if I draw an XY axis, I'm going to shade where my sine is positive. Now my sine is my y's, and my y's are positive in quadrant 1 and quadrant 2. Now my cotangent is the same as my tangent in terms of sine, and I want my cotangent and my tangent to be negative. So that's where my x and y are going to have different signs. So in this quadrant here and in this quadrant here, my cotangent is and my tangent are both negative. So where do I have both shadings? I have both shadings right here in quadrant 2. That's where that angle has to be. That is the only quadrant that will satisfy my cosecant being positive and my cotangent being negative at the same time. On number 3, example 3. So if I'm thinking about this, I am going to be trying to figure out first, where is my sine positive? Okay, not where is 4/5, but where's my sine positive? So my sine is positive above the x-axis. Now, where is my tangent going to be negative? My tangent's going to be negative in quadrant 2 and quadrant 4. Now, where are both true? That's going to be in quadrant 2. So I'm going to be drawing a triangle in quadrant 2. So this triangle is going to be in this quadrant. My angle theta is going to be right here. And for this, I know that my sine of theta is 4/5. So opposite over hypotenuse. Now, I need to find my x here, and I can using Pythagorean, but most of us will recognize this as a 3, 4, 5. Now, this is not going to be 3, it's going to be a -3 because of the quadrant I'm in. I'm on the negative side of the x-axis. So now, when I'm trying to find these answers, and I'm trying to find the cosine, a little smaller, the cosine of theta, I'm going to do adjacent, which is -3, over hypotenuse, which is 5. Now my cosecant of theta is going to be the reciprocal of my sine. I actually already knew my sine. It was 4/5. So this is going to be 5/4. And those are my answers. Now, on the next section, here we're going to be thinking about a graph of a line. Okay, we can add on a graph if we want. So again, blank graph. And let's just say I grab this one again. Now, I want to find the terminal side of this angle theta from this line, and this line is not in a nice form that we usually like to graph it. So I'm going to get it in Y form. So I'm going to subtract my 4x. I'm going to divide by 3, and I get negative 4/3 x. So I'm going to draw this in. And so for this, my y-intercept is going to be 0. And then I'm going to be going down 1, 2, 3, 4 to the right, 1, 2, 3. And then I can draw my line for this. Let me draw a straighter line. And so now when I do this, what I'm looking for, let me just kind of make it a little more obvious. This is the point here. They told us they wanted in quadrant 4, so I'm going to be down in quadrant 4. And so I am looking for this right triangle. That's what I'm dealing with, that right triangle. Okay, and I'll make it a little fainter. So that's the right triangle. So now if I'm looking at this, this is going to be 3. This is going to be a negative 4. And if I do Pythagorean, this is going to be 5. So I have a 3, 4, 5, but it's a 3, negative 4, and 5. Now, where is my angle? My angle is right here, always by the origin. And so when I'm doing this, my sine is opposite, which is negative 4, over a hypotenuse, which is 5. My cosine is adjacent, which is 3, over a hypotenuse, which is 5. My tangent is opposite, which is negative 4, over adjacent, which is 3. And all of these are going to be the reciprocals. So the reciprocal of sine is cosecant. So I'm going to take my negative 4 over 5, and I'm going to flip it. And I get a negative 5 over 4. My cosine's reciprocal is secant. So I'm going to take 3/5 and make it into a 5/3. My tangent and cotangent are reciprocal. So I'm going to take negative 4/3 and make it into a negative 3/4. And those are our answers. Now, in this next section, we're going to be doing dealing with particular angles, okay? And I'm going to be drawing a unit circle for this. So let me get, again, my unit circle length. Okay, so the values I'm going to be looking at, I'm going to be looking at 0, which again, I'm going to have this be a unit circle, which is 1, 0. This is pi halves, which is 0, 1. This is pi, which is negative 1, 0. Let me make that look like a negative 1. And this is 0, negative 1. Now, when I'm dealing with cosecant, which is what this whole section right here is, all of these are cosecants, I'm going to be dealing with sine, the reciprocal of sine. So let me just find the sine of each of these. So the sine of 0 is going to be 0 because that's my y coordinate. The sine of pi halves is going to be 1, again, y coordinate. The sine of pi is going to be 0. And the sine of 3 pi halves is going to be -1. So now I'm going to take the reciprocals of these. So this is going to be 1/0, which is undefined. Reciprocal of 1 is 1. The reciprocal of 0, again, is going to be 1/0 is 1/0, which is undefined. And the reciprocal of 3 pi halves is going to be reciprocal of -1, which is -1. Cotangent. Okay, now cotangent, I could find the tangent, but what I want to remember is that cotangent of an angle is the x over y. So I'm just going to take the x over y. So for 0, I'm going to have 1/0, which is undefined. For pi halves, my x over y is going to be 0/1, which is 0. My cotangent of pi is going to be -1/0, which is undefined. And my cotangent of 3 pi halves is going to be 0/-1, which is 0. So my cotangent and my tangents are going to be 0 and undefined at each of these 4 values. Okay. Wherever my cotangent is undefined, my tangent is going to be 0. Wherever my cotangent is 0, my tangent is going to be undefined. Okay, next. So the next section, we're going to be talking about reference angles. And we've dealt with reference angles before. Now, what we're going to be seeing here, let's get it to stay, sorry. What we are seeing here is that these reference angles are going to be dealing with these in terms of both radians and degrees. Now, whether I'm dealing with radians or degrees, I care about the angle that it is making from that terminal line to the x-axis. So this is the angle I'm looking at. Over here, even though the angle I had was this theta, which goes all the way to here, I want the distance from here to here, that angle. And so you'll notice that if I'm talking about degrees, going all the way to here would be 180, or radians all the way to here would be pi. I'm short from that. So I'm either going to take 180 minus my degree or pi minus my radian. Down here, if I'm in quadrant 3, again, I'm going all the way from here to here in terms of my theta, but my reference angle is going to be this. And since I've gone more than 180, I'm going to take my angle minus 180, or I've gone more than pi, I'm going to take my angle minus pi. Over here in quadrant 4, again, I'm looking for this. Even if I'm going all the way to here, I want how short was I? How much is the distance, angle distance from here to here? So since I didn't quite make it to 360, I'm going to take 360 minus the angle. Or I did not make it to 2 pi, I'm going to take 2 pi minus the angle. Okay, so now we're going to think about it here. So I'm just going to add in, I probably should have saved this, a unit circle blank. And let me just copy that. So I've got it for all of these. Okay. So we got to pay attention to whether we're dealing with radians or degrees. If they give it to you, the angle in degrees, you give me the reference angle in degrees. If they give you the angle in radians, you give it to me in radians. So if I'm looking at the first one, which is 213 degrees, understand that we're going this direction, positive direction, Going all the way to here would be 180 degrees, right? Well, I'm going beyond that, okay? Because that's 180 degrees. Let me just write it down. So this is 180 degrees. This is 270 degrees. So I'm going to be somewhere in between there. So if I was to draw this angle would be going here to somewhere in here. I'm not going to be exact. And I am going this direction, which is 213 degrees. Well, I'm not wanting that. I want the distance from here to here. And so that distance, I'm going to be taking my 213 degrees and I'm going to subtract 180 degrees and I'm going to get 33 degrees. That is going to be my reference angle. That is what this right here is. From here to here is 33 degrees. That's what that angle is. Okay. Now this one is 1.7 radians. Okay, they don't have the word there, radians, but they don't give us a degree symbol. So I'm going to be thinking of this in radians. This is 0. This is pi, but I'm going to think of pi as 3.14. I'm going to think about it as a decimal. Now to figure out this, I'm going to take pi or 3.14 and divide it by 2. And when I do, I get 1.57. So that's 1.57 radians. So this angle here, 1.7 radians is starting here and it's coming over to here. And again, the distance from here to here is 1.7 radians. What I want is this distance. How far is it from here? How far are we from the x-axis? So since I'm dealing with radians and I did not quite make it to pi, I'm going to go pi or 3.14 minus 1.5, not 1.57, sorry, 1.7. And I'm going to end up with 1.44 radians. And that is going to be my answer. So again, this is going to be 1.44, and that's radians. Now, the next one is in degrees. It's 144 degrees. So this is 0, this is 90 degrees, and this is 180 degrees. So we're going to be in quadrant 2. So I'm going to go from here, not quite to 180. And so the going from here to here is 144 degrees. What I'm trying to find is this here. And so I want this little slice. What is that? So in order to find that, I'm going to take my 180 because I didn't quite reach there. And I'm going to subtract 144 to see how far off. And when I do, I get 36 degrees. So that's going to be my reference angle. So this is going to be 36 degrees. Now, the next idea here, they're having us evaluate this. So in this section, we're talking about radians, we're talking about degrees. We're using the unit circle if they're giving us these angles in terms of radians or degrees. Or maybe we have ones like this where maybe I'm not dealing with a unit circle, but I am dealing with a circle with a different radius. So in this situation here, when I'm evaluating this, okay, I'm going to get that blank unit circle. And on the worksheet, I give you guys a blank unit circle with the unit circle blank. And let me just put this here. And I'm just going to copy. Okay. So when I'm dealing with 5 pi thirds, okay, I have to think about what quadrant we're in. We are going to be in quadrant 4. So usually I give you like 3 dots here for my pi 6, my pi fourths, and my pi thirds, okay? So we're going to be right here. This is where we are at 5 pi thirds. And so for this, if we're thinking about a triangle, what are the coordinates here of this point? Well, this point, if you're thinking about it, how are we moving? We are moving. Let me just grab something to emphasize it. Let me choose this. Okay. So we are going short, comma, long. Short, comma, long. So every time I say short, you're thinking 1/2. Every time I'm saying long, you're thinking root 3 halves. So for this is going to be 1/2 comma root 3 halves. That is this point right here. Sine is going to be the y coordinate. So that's going to be root 3 over 2. Now this next one, I'm dealing with angles as degrees, and we're going this direction. We're going this direction. Okay, that's the direction we're going. Okay, this direction. And they want us to go 60 degrees. And so when I'm doing that, if I again have my 3 dots here, my 60 degrees is going to be this one right here. So again, we're dealing with this, okay? And again, it's actually the same one we just had on the last problem. So I've got short, comma, long. And I apologize over here. I forgot to put my negative sign because my y is negative there, okay? I just paying attention right now. That should have been a negative because of the quadrant I'm in. My y's are negative in this quadrant. So down here, this one is going to be a negative root 3 over 2. That's going to be my so since the point is 1/2 comma negative root 3 halves, your cosine is equal to your x. So the cosine of negative 60 degrees, and really this should be in parentheses. I think that parentheses disappear. That way you don't think it's a minus, is 1/2. On the next one, tangent of 11 pi 6, that is going to also be in quadrant 4 as I'm going around my unit circle. So again, if I'm going around my unit circle positive this time, I'm going this direction, I am going to end up in that quadrant. So I have my 3 marks here. I want 6 this time, so it's going to be this one right here. And so when I draw this and I'm trying to find the coordinates, again, I want to pay attention to how am I moving. I'm going long, comma, short. I'm going long, comma, short. And when I say long, I mean root 3 over 2. And when I say short, I mean 1/2. So the coordinates of this point are going to be a positive root 3 halves, comma, a negative 1/2. Now in this case, I want tangent. Tangent is y over x. So I'm going to be taking negative 1/2 over root 3/2, which means it's a negative 1/2 times the reciprocal of 2 root 3 as 2 over root 3. My 2's are going to cancel out. I end up with a negative 1 over root 3, but remember, we need to rationalize. So we're going to times the top by root 3 and the bottom by root 3. And when I times the top by root 3, I get a negative root 3. When I times the bottom by root 3, I get 3. And that's my answer. Okay, on the next example, when we're dealing with the angle theta, and this is in quadrant 3. So let's see, I'm just going to come here and copy this. So when this is in quadrant 3, they're telling us because sine is negative and sine is negative in these two quadrants, okay? So I could have been in either of these spots. They are telling us right here that we're in quadrant 3. So when I draw this, and again, my angle theta is here. My sine is opposite. Now this is going to be a negative 5 because of my location over hypotenuse. Hypotenuse is always positive. Now I'm going to do Pythagorean. Some of us might recognize this as a 5, 12, 13 right triangle. And it's not going to be a 12, it's going to be a negative 12. And obviously I did not draw this to scale. So now I want to find the secant. Now remember, secant is the reciprocal of cosine. So my cosine is adjacent over hypotenuse. So that means my secant, which is what I wanted, is going to be the reciprocal of that. So it's going to be a negative 13 over 12. My tangent, remember, is y over x. So, or opposite over adjacent, I guess in this case is probably better to think of. So opposite is negative 5, adjacent is negative 12. Clean that up, that's a positive 5/12. And that's my answer. So on the next section, they want us to give the answers in exact form in degrees and radians. So again, let me just paste this. Okay. And I'll just make this a little bigger. Okay. So here, when we're dealing with sine, remember that sine is negative in 2 quadrants. So I should be getting 2 angles from 0 to 360 and 2 angles from 0 to 2 pi that give me that negative root 3 over 2 for the sine. So I am going to be in this quadrant and this quadrant, okay? So when I'm dealing with this, again, on the worksheet, I'll give you the unit circle with the little dots there. If I'm thinking about my sine being root 3/2, I want to pay attention to short, long. So I want my sine to be long. I want my y to be long. So if I'm going this one, I'm going short, long. Where if I went to this one, I'm going long, short. So I want my y to be the long. So that's short, long. I'm going to be right there at that point. That's where I'm going to be. So for this one, I'm going to be at this point right here. Let me just change the color. This point right here. Okay. And that is going to be, in terms of degrees, remember this is 180 degrees. So this is going to be 60 beyond. This is going to be 240 degrees. That's going to be one answer. Now, it's also going to be here because that would also be the same coordinates, but different signs. So here, this is going to be 300 degrees. So those are two answers. Now, I also want this in terms of radians. So radians, these are thirds. So this is going to be 4 pi thirds, and this is going to be 5 pi thirds. So the ones in red, let me get rid of the 180 so you don't think that's an answer. The ones in red, the 240 and the 300 degrees, are the two angles in degrees that would give me a negative root 3 over 2 for sine. The two angles in teal are the radian versions of the angles that would give me a sine that's equal to a negative root 3 over 2. Okay, cosine. Cosine positive. Cosine's positive in these quadrants here. A quadrant 1 and 4. Now, when I'm dealing with root 2 over 2, and I've got my marks, remember, this is going to be my force or my 45. So I am going to be here, and I'm going to be here. Now, in terms of angle degrees, this is going to be 45 degrees. This one's going to be short of 360. This is going to be 315 degrees. When I'm dealing with my radians, this is going to be pi force. This is going to be 7 pi force. So those are my two answers in degrees and my two answers in radians. On the next section, use a calculator to find two values that satisfy each of these. So this is going to be the similar idea, okay, as what we just did. But, so let me just kind of get another one of these. But what's going to happen this time is these are not nice ones. These are going to be ones that I'm going to find on my calculator. Okay. And I'm just going to use Desmos to help us with this. So first off, on the first one, they want us just to use degrees. So I'm going to get 2 degree answers. On the second one for B, they want radians. Okay. So where is my cosine negative? My cosine's negative in these two quadrants here, in quadrant 2 and in quadrant 3. So I'm going to be looking within those. Now, what I'm going to do is I'm really going to find this as a reference angle, okay? And so instead of thinking of it as, so instead of thinking of getting it on the negative side, okay, having this be the negative, I'm going to find it as a positive. So what I'm going to do is I'm going to do cosine inverse, okay, cosine inverse of 0.5736. Now that's not going to give me the answer I'm looking for. It's going to give it to me in quadrant 1, okay, but I like to find in quadrant 1 and go from there. So let me get a Desmos up. Okay, so I just got a scientific Desmos up. And I want to put this into my calculator. So I'm going to come here to function and I'm going to do cosine inverse. And then I'm going to type in 0.5736. Again, I'm doing it as the positive X value. And I'm going to find where it is in quadrant 1. And they want it in degrees, so I have it in degrees. So this is going to be the angle, 54.998. So about 58 degrees. Okay, about 58 degrees. So let me just move this aside for a second. So this is going to be, actually, I'm going to move it over here. So this is going to be about 55 degrees. So let's just say I am here. And again, this is 55 degrees. So what I want is, I'm going to want this, I'm going to draw it in purple. I want it here and I want it here. I want this and I want this. And I'm going to be trying to find 55 degrees above the x-axis and 55 degrees below the x-axis. So basically, I'm going to be taking 180 minus 55 to find the one in quadrant 2, and 180 plus 55 to find the one in quadrant 3, because I'm 55 above and below. So if I'm putting this in my calculator, and let me just clear this, I'm going to be doing 180, 180. Let me clear that again. I'm going to be doing 180 minus 55, which is going to be 125 degrees. And I'm going to do 180 plus 55, which is 235 degrees. So those are going to be the two angles. So again, this one was 125 degrees. And this one ended up being 235 degrees. And so those are going to be our two answers. On the next one, I'm going to be doing sine, and they want us to figure out where sine is negative. And my sine is going to be negative in quadrants 3 and 4. So I'm going to be somewhere in 3 and 4. Okay. This is what I'm looking for. I'm going to again find it as the positive, which is going to be in quadrant 1, and then use that to help me. We also want this to be in radians, not in degrees. So I am going to do sine inverse of, and again, I'm going to think of it as the positive y instead of the negative. So that's going to be in quadrant 1. So I'm going to go 0.64. I don't know why I can't write right now. 0.6428. And that's going to be giving me my answer in quadrant 1. So I'm going to get this back again. Okay, let me just clear all. I'm going to come to sine inverse. Now I want this in radians and not degrees. Okay. And so when I'm going to type this in, I'm going to type in 0.6428. Again, I'm doing it as the positive. I end up with 0.6981. Now, if I click this here, I'm going to see that that's about 40 degrees. Okay, but I want the radians. Okay, so let's say it's about 0.70 because this 8 will push this up. So 0.70. Okay, so that's about equal to 0.70. Now, over here, I'm going to be, well, it's about 40 degrees. So let's just say it's here. Okay. So this was 0.7 radians is what I'm talking about. So that means over here, I'm going to be 0.7 above pi and 0.7 below pi. So I'm going to go pi minus 0.7, and I'm going to go pi plus 0.7. So if I get my calculator back here, I'm going to go pi minus 0.7. I get 2.44. And when I go pi plus 0.7, I get 0.384. So I'm going to have 2.44 and 3.84. So Again, this is going to be 2.44 here. And again, this is radians. That's one answer. And the other answer is going to be 3.84. And again, this is in radians. That's going to be my second answer. And that's the end of these notes on section 4.4 of our chapter 4 math analysis book.